All right, so today what we're going to be doing is looking at 2016 number 3, okay? So on 2016 number 3, it looks like we're given the graph of f, and it says that the figure above shows the graph of a piecewise linear function f for x between -4 and 12. The function g is defined by g of x equals the integral from 2 to x f of t dt. And we're asked in part A, does g have a relative minimum, relative maximum, or neither at x equals 10? Justify your answer. So for a minimum or maximum, what am I looking for, right? What do I need to be thinking of as I try and find a minimum or maximum, or even neither, okay? So in part A, let's kind of remind ourselves when a minimum or maximum might occur. So I have the function g of x equals the integral from 2 to x f of t dt. And remember that a maximum would look something like this on the original function, and my derivative would be changing from positive to negative, right? On the original function, a minimum would look something like this, and my derivative would be changing from negative to positive. So the first thing I need to look at is my derivative, right? So what's the derivative of g? Well, remember when you take the derivative of an integral, all you have to do is just plug in the bound. Okay, so the derivative of g is equal to f of x. So when I'm trying to figure out if I have a minimum or maximum, I'm just looking at f of x. Okay, and that's what the graph is. That's what the graph that I'm given. Okay, so at x equals 10, does f change signs? Yes, f of 10. So yeah, g prime of 10 equals f of x, or equals f of 10. Yeah, that equals 0, but I don't change signs, right? So I would say that at x equals 10, we don't have a minimum or maximum because g prime of x equaling f of x does not change signs. Okay, so if it changed sign from a positive to a negative, it'd be a maximum. If it changed sign from a negative to a positive, it'd be a minimum. But because I don't change signs, I'm neither a minimum nor a maximum. Okay. Part B, does the graph of g have a point of inflection at x equals 4? Justify your answer. So for part B, again, we're going to look at the original function. I'm going to rewrite it just so we can see it again, right? So g of x equals the integral from 2 to x of f of t dt. And there's two different ways that we can look at a point of inflection. We always, though, want to go back to what's given in the problem, right? So g prime of x is equaling to f of x. So for f of x, I need to look at x equals 4. Okay? For the first derivative, we're looking for where I change from increasing to decreasing, or if I change from decreasing to increasing. Okay, that would be where your points of inflection are. This is for the first derivative, right? For the second derivative, if you wanted to think about it that way, g double prime of x is just take the derivative again, and that's f prime of x, okay? And I would have a point of inflection on the second derivative if I change from positive to negative or negative to positive, okay? But because I'm given the graph of x, I want to go back to what I'm given, right? So I want to use this function here. So at x equals 4, I want to see, am I changing from increasing to decreasing or decreasing to increasing? So at x equals 4, the graph goes up and then it comes down, right? So that'd be increasing and then decreasing, so that would be a point of inflection. So I would say that at x equals 4, g has a point of inflection because g prime of x equaling f of x changes from increasing to decreasing. Okay? Okay, if we wanted to talk about this one, even though we probably shouldn't, and let's steer clear of this reasoning for this problem in particular, because we are given f of x, I always want to go back to what I'm given. But for this part, I would be looking at the slopes of f. Okay, so at x equals 4, the slopes of f change from positive slopes to negative slopes. So I would end up with a point of inflection with that justification as well. But again, always go back to what was originally given, in this case, the graph of f. Okay? Okay, part C, find the absolute minimum value and the absolute maximum value of g on the interval -4 to 12 and justify your answers. Okay? Do you remember how to find a minimum or maximum on a closed interval? Maybe. Hopefully we've seen this quite a few times, so we should be familiar with this. To find a minimum or maximum on a closed interval, we're going to need to do a candidate test. So the first thing that I want to look at are the places where I'm going to have critical numbers. So g of x is equal to the integral from 2 to x of f of t dt. And so I first want to look at where are my critical numbers. And remember, a critical number occurs when the first derivative equals 0. And in this case, my derivative is equal to f of x. So where does f equal 0? So let's go back up to the graph here. The graph of f is equal to 0 at a few different places, -2, 2, 6, and 10. Now, in part A, we've already discussed whether I have a minimum or maximum at 10, and we already said that there is neither. So we're not going to use that as a critical number, right? It's not a potential candidate for a minimum or a maximum. X equals 2 does not change signs, right? It doesn't change signs from positive to negative or negative to positive. So again, I am not going to have a minimum or maximum at x equals 2. At -2, I have the possibility of I do have a minimum or maximum because the graph changes from negative to positive, right? The graph of f changes. My first derivative changes from negative to positive. At 6, I change from positive to negative, okay? That first derivative changes from positive to negative, so I could potentially have a maximum here, and I could potentially have a minimum there, okay? So x equals -2 is potentially, what do we say, a minimum. What else did we say? We said that x equals 2, even though it equaled 0, it was neither. It's not going to be a minimum or a maximum because it just doesn't change signs. X equals 6, we said, could be a potential maximum. And x equals 10 was neither. Okay? All right, so for my candidate test, I want to use the possibilities, which would be minimum and maximum, but then I also want to use my endpoints of the interval, which were -4 and 12. Okay? All right, so let's set up my t-chart. So I'm going to go -4, 2, 10. Oh wait, -2, 6. Oops, forgot those. -2, 6, and then 12. Okay, we're not going to use 2 or 10. So we need to plug these into the g of x function. Okay, so the integral from 2 to -4. Right, because g of -4 is equal to the integral of f of t dt. So what we need to do is we need to look at the integral from 2 to -4. Now remember, with an integral, the bounds need to always be increasing. So when I flip it, it will make it negative. All right? And this is just my scratch work off to the side. My actual values in the table will be what counts. So for my scratch work here, I'm just going to leave it as the negative integral from -4 to 2, and we're going to go up to the graph here. Okay? So from -4 to 2, because I'm probably going to be going back and using a lot of these rectangles, let's go ahead, or these triangles, I'm sorry. Let's just go ahead and find their areas. I think it won't be so bad because they're just pretty simple triangles here. On the first one, I have 1/2 base times height. So the 2's cancel out. This is an area of -4. For the next one, so that was this shape. For the next shape here, I think I have the same exact numbers, right? 1/2, a base of 2, a height of 4. So that's just going to be positive 4. From 0 to 2, same triangle, right? Just the mirror of it, so to speak. I'm going to have 1/2, base of 2, height of 4. So again, this one has an area of 4. On this next one here, it looks like I have a base of 2 and a height of 4 again. So this one's an area of 4. For my next one, well, 1/2 base times height would also get me 4. For the next one here, let's use light green. Hopefully you can see that. 1/2 base times height, a base of 2, height of 4, but this time it's beneath the x-axis, so it's negative 4. You could probably guess what the next one's going to be. Whoops. Right, so this one is again going to be negative 4. And then the last part here, from 10 to 12, the base is 2, the height is negative 4, so, and because it's beneath the x-axis would be an area of negative 4 as well. So the integral from negative 4 to negative 2, or negative 4 to positive 2. So negative 4 to positive 2. Okay, so the negative area would cancel with some of the positive area, right, from negative 4 to 0. So from negative 4 all the way to 0, that would cancel out with each other, right? It's above and it's below. So the only area that really matters here is from 0 to 2, which is 4. But because I have that negative sign out in front, this is going to be negative 4. Okay? Now for negative 2. Now we're going to go, so g of negative 2 is equal to the integral from 2 to negative 2 of f of t dt. Same idea, right? Because my bounds are not increasing, I'm going to flip them and make it negative. Okay? So now the area from negative 2 to 2. So this time the area from negative 2 to 2 is this triangle here. But if I add those two triangles together, I'd get 8. The negative sign would make it negative 8. Okay? 6. So this time we're going for g of 6 is equal to the integral from 2 to 6 of f of t dt. The bounds are already increasing, so I can just look at the area here from 2 to 6. Let's erase that, and we're talking about this area here. So from 2 to 6, that's just adding the two triangles together, and I'm going to get positive 8. Okay? And then lastly here, from g of 12 is equal to the integral from 2 to 12 f of t dt. So if I take a look at the graph from 2 to 12, I've already shaded in those two because I am going from 2 to 6. Now from 6 to 10, those would cancel out with those triangles above, and so I'm just left with this here at the end, which is negative 4. Okay, so I have my candidate test. I performed the candidate test, so now what I'm looking for is the minimum value and the maximum value. Okay, so the minimum value is negative 8 at x equals negative 2, and the maximum value is 8 at x equals 6. Okay? All right, so that's part C. For part D, for x between negative 4 and 12, find all intervals for which g of x is less than 0. Okay, so g of x is equal to the integral from negative, or from, let's see, what was it, 2? Yep, 2 to x. Okay, so I want to know, when is this function less than or equal to 0? All right, and that function is just the integral from 2 to x f of t dt. So when is that area going to be less than or equal to 0, right? Remember, an integral is just the area under the curve. So when is that area under the curve less than or equal to 0? Okay, so let's go from starting with 2. Okay, so starting with 2, right? From 2 to 4, I'm positive 4. So that's not going to work, right? From 2 to 6, right, this area is all going to be positive, so that's not going to get me any negative area. 6 to 8, right? So if I tack on that from 2 all the way to 8, I have more positive area than I have negative area, right? So that's going to end up being a positive value. If I go all the way out to 10, those all just cancel out. And regardless, as I get closer and closer to 10, I still am going to have more positive area above the x-axis. Then at 10, I change, right? So far, this has all canceled with that. And because of that, anything that I have after 10 is just going to be negative area. So from 10 to 12 would be one interval. So anything from 10 to 12 would give me a negative area, okay? But that's not all of it, right? Because I only went from 2 above, but now I need to look at from -4, right? Going backwards to -4. So if I'm going to go backwards, I'm going to need to switch my bounds, right? If I switch the bounds, they go from x to 2. And that needs to be less than or equal to 0, just like before. To make it easier for myself, I'm going to divide it by a negative. And remember, when you take an inequality and divide by a negative, we need to switch the sign. So leading up to 2, I need to figure out when the area is greater than 0. Okay? So let's take a look at the graph. Now we're going to go backwards. So if I'm starting at 2, let's see. So now I'm going to start at 2 and head backwards, right? Okay, so from 2, right? So from 2 to 0, I'm positive area. So if I take the integral from 0 to 2, that's going to be a positive area. So there's no issue there. I want it to be positive, right? That's what we said here. I want the integral to be greater than or equal to 0. So that's a positive area, so that's good. The integral from -2 to 2, that's still all above the x-axis, so that's still good. Now the integral from -4 to 2, right? At that -4, I'm just -4 and that +4, those would cancel out. So no matter what, those end up canceling out and I still have this +4 here, right? So everywhere between -4 and 2, I'm going to end up with positive area. Okay? Okay, so it's these two intervals. All right, so let's talk about points real quick on this one. On part A, you would get, well, before you even get anything, they're going to look on your paper for this line, right? As long as you have that line in parts A, B, C, or D, you're going to get 1 point. If you have that in A, B, C, or D, you will get 1 point. That's pretty easy. That's pretty nice, actually. In part A, you'll get 1 point for your answer with justification. In part B, you're going to get 1 point for your answer with justification. In part C, you're going to get 4 points for this problem. 1 point for identifying 2 and 6, -2 and 6. 1 point for using the endpoints. And then you're going to get 2 points for correctly identifying the minimum and maximum values. Okay? And then in part D, you're going to get 2 points altogether, all or nothing, for these two intervals here. Okay? All right, let me know if you need help.